Section 7.1, Simplify, Multiply, and Divide Rational Expressions. Well, first of all, what does it mean to be a rational expression? Rational just means fractions. So we're going to have lots of fractions in this chapter. We're going to get really good at multiplying, dividing, adding, subtracting, and solving with fractions. Well, the first thing you want to do if you see the directions to simplify or multiply in a sense is you need to factor. So all of the factoring techniques that we learned in chapter 6 are going to come into play in chapter 7. So you might want to take out your class notes and look back at all the different factoring that we learned back in chapter 6. So to reduce or simplify, same direction, the first thing you want to do is factor the numerators, all the numerators, and all of the denominators. So this is a chapter that I always tell students to make note cards of the direction. So one of the directions would say to reduce, and then on the back of the note card you're going to write factor. This is a chapter where you have to understand what to do right off the bat, and it's not always exactly what the direction says. So when it says to reduce or simplify, the first thing you want to think about is to factor all the numerators and denominators if needed. Now what do I mean by if needed? Well, you need to if you see a plus sign or a minus sign. Anytime you see plus signs or minus signs, you need to think factoring when the direction says to reduce or simplify. Next, you're going to cancel any like factor that appears on top and bottom. So any factor that appears in the numerator and the denominator can cancel out. One thing I want you to be very cautious about is when you have glue. Glue is when you have a plus sign or a minus sign. Whenever you see a plus sign or minus sign, that sticks those terms together like glue. So if you're going to cancel, the whole factor has to cancel. So number 1, the direction says to reduce or simplify 32c squared d to the 6 all over negative 24 c to the 4th d to the 7th. So if we follow those steps that were listed, the first thing is to factor if needed. Well, when we look at that problem, there are no plus signs or minus signs, so no factoring is needed. I can just go ahead and start reducing. So looking at the 32 over the negative 24, the first thing I see is a negative needs to come up. Remember, a fraction is in simplest form if the negative is not left in the denominator. Now I need to reduce 32 over 24. I see that an 8 can go into both of them. So 32 divided by 8 is 4, and 24 divided by 8 is 3. Now when we're dividing, what do we do to exponents? We subtract, and since 4 is bigger on bottom, I'll leave them on bottom, so 4 minus 2 is 2. If you want to do the top minus the bottom, you'd have a negative 2, and then the c squared would still go down. Again, when you're dividing, you subtract exponents. I'll have a d left on bottom, because 7 minus 6 is 1, 7's bigger, so I'll leave it on bottom. And that's all I can do with that problem. So number 2. X squared plus 3x minus 18 all over x squared minus x minus 6. So looking at the direction, it says to factor the numerators and the denominators if needed. We definitely need to because you see plus signs or minus signs. A lot of students want to go ahead and start trying to cancel the x squareds. You cannot because you have glue. The plus signs and the minus signs sticks all those terms together, so we need a factor. So this is just the C method. Factors of negative 18 add up to positive 3 would be a positive 6 and a negative 3. So x plus 6 times x minus 3. Again, in the denominator, it's also just the C method because the number in front of x squared is 1. So we just need factors of negative 6 add up to negative 1. Those would be negative 3 and 2. So x minus 3 and x plus 2. Now we look to see if there's any factor that appears on top and bottom that we can cancel. There's an x minus 3 on top and an x minus 3 on bottom. Those can cancel, and I'm left with x plus 6 all over x plus 2. We can't reduce the 6 and the 2 because, again, we have glue sticking the x and the 6 together and the x and the 2 together. So we are done. Make sure the only time you cancel is if you have multiplication, and factoring breaks things into multiplication. So number 3. X cubed minus 8 over x squared minus 4. We definitely need to factor because we see the minus signs. X cubed minus 8 is that cubes formula. From section 6.3 in the cubes formula, a cubed minus b cubed turned out to be a minus b. Then we take a and square it, plus a times b, plus b, and then square it. So what is being cubed that gives me an x cubed would be an x. What's being cubed that gives me an 8 is a 2. And that's going to be my a and my b. So the numerator would factor into x minus 2. Then we take x and square it, and we add 2 times x, which is 2x, plus, and then we take 2 and square it, and 2 squared is 4. In the denominator, x squared minus 4 is that difference of squares. So it factors into x plus 2 and x minus 2. Now we look to see if any factor appears on top and bottom, and we see an x minus 2 is on top and bottom, so they will cancel each other out. And we're left with x squared plus 2x plus 4 all over x plus 2. Again, when you use that cubes formula, you'll never be able to factor that trinomial any farther, so you don't need to try. Number 4, x minus 4 over 4 minus x. We do see subtraction, so we need to think about factoring. Well, can we factor x minus 4? No. Can we factor 4 minus x? Not really. So it looks like we're kind of stuck. But do you notice that we are completely opposite? Meaning the x on top is positive, but the x on bottom is negative. And then the 4 on top is negative, but the 4 on bottom is positive. Those are completely opposites of each other. So there's something called a -1 trick. If I take out a -1 from the top or the bottom, but I'll always do it from the top, what happens to my signs? They have to change because I'm factoring out a negative. So the x on top will become negative and the 4 on top will become positive, and do not do anything to the denominator. So all I do is pull out a -1 from the top. Now when I compare the numerator and the denominator, I see that there is a negative x plus 4 factor in common. Just one is flipped the other direction. So they are the same factor, so they can cancel, but what am I left with is a -1. So if you see a factor on top and bottom that looks very similar, but the signs are switched, most likely you can just factor out a -1 and they will cancel. So number 5, 1 minus y over y squared minus 1. Again, the 1 minus y doesn't look like we can do anything to it. Y squared minus 1 is that difference of squares. It factors into y plus 1 and y minus 1. So looking at those factors, none of them cancel as is. But the y minus 1 and the 1 minus y on top and bottom are complete opposites. So we'll take out a -1 from the top. That changes all my signs, so my 1 becomes negative and my y becomes positive. I do nothing to the denominator. So all I do is factor out a -1 from the numerator. Now comparing the numerator and the denominator, the -1 plus y is the same thing as y minus 1, just they're written backwards. So they do cancel because they are the same factor, so I'm left with a -1 on top and a y plus 1 left on bottom. The next direction says to multiply. So what do we actually do when we multiply? We don't start off multiplying. That's where I would make another note card. You're going to start off by factoring. Factoring what? All the numerators and the denominators. So again, when you see the word multiply, do not start off multiplying. So put that on the front of the note card, and on the back of the note card, write the first couple of steps. So factor the numerators and the denominators if needed. How do we know if it's needed? If we see plus signs or minus signs. So cancel any like factors that appear on top and bottom. The last step, step 3, is to multiply any remaining factors. So this is very similar to the steps for reducing or simplifying, but our last step would be to multiply if we have any remaining factors. Again, I want you to only cancel when you have multiplication, so think of glue when you have plus signs and minus signs. When there's glue, think about factoring. So now let's look at to divide. You're going to change division to multiplication. Why? Same exact steps if we had regular fractions. For example, if we had 2/3 divided by, say, 5/9. We wouldn't actually divide, we would change division to multiplication, and we'd flip the second fraction. And we use multiplication rules. So this is the same thing we're going to do with rational expressions because they're fractions. We're going to change division to multiplication. We're going to flip the second fraction, so take the reciprocal, and then we're just going to use the multiplication rules from above. So we're really not ever going to divide fractions. We're going to switch it into multiplication. So looking at number 1, we have 8ab cubed all over 9a squared b times 18ab cubed all over 16a squared b squared. Is there any glue? No, because there's no plus signs or minus signs. So we could multiply straight across, we could cross cancel. So the first thing I'm going to do is I'm going to work with my numbers by cross canceling, and then I'll combine my a's and my b's by adding, because when I multiply I add powers. So 8 can go into 16 2 times, so I'll be left with a 2 down there. And 9 can go into 18 2 times, so I'll be left with a 2 on top. Well, really 2 divided by 2 is just 1. But we'll do that in the next step. Now let's look at our a's. We have a on top times an a on top. When I multiply, I add powers, so I get a squared. B cubed times b cubed, I'll add powers, and I get b to the 6. In the denominator, we have a squared times a squared, we add powers, and we get a to the 4th. And b times b squared is b cubed, again adding the powers. So now let's simplify. 2 divided by 2 is 1. So it's understood to be there because we'll have some other things left over. When I am dividing, what do I do to exponents? I subtract, and so I'm going to get a squared on bottom. And again, when I'm dividing, I subtract exponents. 6 minus 3 is 3 on top. So my final answer is b cubed all over a squared. The 1 is understood to be there, so you do not need to put it. So let's look at number 2. X squared plus 5x plus 1 all over 4x minus 4 times x minus 1 all over x squared plus 5x plus 1. So what's the first step if we're supposed to multiply? Is to start trying to factor. So if we look at the first numerator, that would be the C method, but there are no factors of 1 that add up to 5, so I'll just put it in parentheses to show that it is its own factor. The other numerator was x minus 1. It cannot be factored either, so I'll leave it as x minus 1. In the denominator, 4x minus 4 is the GCF method. Take out what's in common, which is a 4, and I'm left with x minus 1. And again, the x squared plus 5x plus 1 cannot be factored, so I'll leave it as is. At this point, I'll cancel any like term that appears on top and bottom. X minus 1 appears on top and bottom. X squared plus 5x plus 1 appears on top and bottom. So be very careful with your answer. Your answer is not 4. What's on top is a 1, and the 4 is left on bottom. So your answer is 1/4. So looking at number 3, x squared plus 7x plus 12 all over x minus 5 divided by x squared plus 9x plus 18 all over x squared minus 7x plus 10. So when we see division, we need to change division to multiplication and flip our second fraction. So division becomes multiplication, and we flip the second fraction. So x squared minus 7x plus 10 would go on top, and x squared plus 9x plus 18 would go on bottom. All of the factorings for the top numerator and the other fraction are going to be just the C method, so I'm going to let you finish that on your own. The final answer in factored form would be x plus 4 times x minus 2 all over x plus 6. Since the last step says to multiply, you could go ahead and FOIL out the numerator and get to the final answer. For the test, I'd go ahead and accept that as is to save time. But again, in my math lab, they're going to want you to FOIL that out because the last step is to multiply remaining factors. And that would give you an x squared plus 2x minus 8 all over x plus 6. Either answer I will accept on the test. So let's look at number 4. We have multiplication, so we don't need to do any flipping. But what method are we using here? We're using the AC method with 3x squared minus 17x plus 10 all over 3x squared plus 7x minus 6 times 2x squared plus x minus 15 all over 5 minus x. So 3 out of the 4 terms are going to have to be factored. So looking at 3x squared minus 17x plus 10, I'll do this one, and I'll let you do the others. How do we start off the AC method? We multiply a times c. So a times c is 30. We need to find the factors of 30 that add up to b. And what is b? Negative 17. So the factors of 30 that add up to negative 17 are a negative 2 and a negative 15, because when I multiply I get a positive 30, but if I add I get a negative 17. Now we would love to jump to our answer, but the AC method is the one that takes a lot more work. We put the negative 2 and the negative 15 in place of the b term. So we have 3x squared minus 2x minus 15x and then plus 10. So replace the b term with those two terms. Then we factor by grouping. Grouping the first two, we see that there's just an x in common, so we're left with 3x minus 2. Grouping the second two, between a 15x and a 10, we see there's a 5 in common. So pulling out a negative 5, we end up with a 3x. Be careful here, it's a minus 2 because we took out a negative 5. Remember we said if these are not the same, what's in parentheses, we know we did something wrong, but they are the same, so we take out the 3x minus 2, and in parentheses we're left with the x minus 5. So all I have done is I have factored that first numerator. So let's draw one long line. You're going to go ahead and do the AC method for 2x squared plus x minus 15. If you do the AC method there, you'll end up with 2x minus 5 times x plus 3. In the denominator, you're also going to have to do the AC method with 3x squared plus 7x minus 6, and that's going to factor into x plus 3 and 3x minus 2. With the last denominator, 5 minus x, we'll go ahead and write it as 5 minus x for now, but maybe that one's still going to be able to be canceled. So now we'll look for any terms that appear on top and bottom. We have a 3x minus 2, so those are going to cancel on top and bottom. We have an x plus 3, and that will cancel on top and bottom. If we look at the x minus 5 and the 5 minus x, we see that those are the same, but just flip-flopped with the signs. So how do we remedy that? We take out a negative 1 from either the top or the bottom. So I'll take a negative 1 out of the top. That's going to change my x to becoming negative and my 5 to becoming positive. So now I do have like terms. So negative x plus 5 on top will cancel with the 5 minus x. They are the same factor, just written backwards. So what am I left with on top? A negative 1 and a 2x minus 5. So I'm left with this negative 1 times this 2x minus 5. So distributing in the negative 1, I get a negative 2x plus 5. So don't forget about that negative 1 trick. It does come into play a few times. So the next part of this section is about rational functions. Again, rational meaning fractions, but we're going to have function notation. So given g of x equaling x minus 2 over x minus 1, I want us to find the following: g of 0, g of negative 2, g of negative 1, and g of 1. So what does that actually mean to do? Well, that means to find g of 0, we're going to let x be 0. So plugging in x being 0, I get 0 minus 2 all over 0 minus 1. Again, anytime I do a substitution, I use parentheses. Don't really need them in this problem, but it's a good habit to get into. So I get 0 minus 2 over 0 minus 1, which gives me a negative 2 over negative 1. So my answer is 2.
So this should say g of 0 equals 2 instead of g of 2 equaling 2. Sorry for that.
Looking at g of negative 2. Again, that means wherever we see x, we plug in a negative 2. So negative 2 minus 2 all over negative 2 minus 1. Well, we get negative 2 minus 2, which is negative 4, and negative 2 minus 1, which is negative 3. Two negatives make a positive, so I end up with 4/3. So g of negative 2 equals 4/3. Negative 2 went in, 4/3 came out. Now let's look at g of negative 1. So when I plug in x being a negative 1, let's see what does that look like. So negative 1 minus 2 all over negative 1 minus 1. So negative 1 minus 2 is a negative 3, and negative 1 minus 1 turns out to be a negative 2. And negative divided by negative is a positive, so g of negative 1 is going to equal a positive 3/2. The x value went in as negative 1, the y value coming out is 3/2. And lastly, let's find g of 1. When I want to find g of 1, what does that mean I do? I plug in x being a 1. So I end up with 1 minus 2 all over 1 minus 1. So 1 minus 2 is a negative 1, and 1 minus 1 is 0. You can't divide by 0, so my my g of 1 is undefined. You can have a 0 on top, that's fine, but you can never have a 0 on bottom because you don't have a foundation. So whenever you have a 0 in the denominator of a fraction, you know that that value is undefined there. So g of 1 is undefined. Not no solution. We're not trying to find a solution. We just wanted to evaluate g of 1. So given that h of x equals x squared minus 4x minus 5 all over x squared plus 5x plus 6, I want us to find the following: h of 5, h of 2, and h of negative 2. I'll do the first one for you, and I'll leave you the other two to do on your own. So if I want to find h of 5, that means I'm going to plug in x being 5. Again, using parentheses anytime I do a substitution. So I get 5 squared minus 4 times 5 minus 5 all over 5 squared plus 5 times 5 plus 6. So on top, I'm going to end up with 25 minus 20 minus 5 all over, on bottom, 25 plus 25 plus 6. So 25 minus 20 minus 5 is 0, and 25 plus 25 plus 6 is 56. We're okay with 0 on top. So 0 divided by 56 is 0, which tells me that h of 5 is going to equal 0. The 5 went in as x, the y value that comes out is 0. So you'll try h of 2 and check and make sure you get an answer of negative 9 over 20. And then you're going to try h of negative 2, and you should get that h of negative 2 is undefined. So that should give you 0 in the denominator. So the last part of this section is talking about domain. And what is the domain? The domain is looking at the x values and seeing what values you can use. So the domain is a set of input values we are allowed to use. Now, when are we allowed to use values? When we plug in a value, it doesn't give us a 0 in the denominator if we're dealing with rational equations or rational functions. So when we look for the domain, we just want to make sure that our denominator never becomes 0. So here are the steps to find the domain. First thing is you're going to take the denominator and you're going to set it equal to 0. Why would you do that? Because that's the thing you don't want to happen. You don't want your denominator ever to become 0. Then you're going to solve that equation. It should be either linear or quadratic. Then you're going to throw out any points that make the denominator 0. So get rid of those points, and that's your domain, whatever's left over. So looking at number 1, it says state the domain given that f of x equals x plus 4 all over x minus 2. The only direction says is to state the domain. So again, I would put this on the front of a note card, and on the back of the note card, what are the first few steps? So to state the domain, I take the denominator, which is x minus 2. I set it equal to 0. When I solve that equation, I get x equaling 2. So that's the thing I want to throw out. So we're going to use set notation. We've seen it before. We have these little squigglies. And it's a set of all x's. Draw your line down that means such that, and then put this in the next box. And we get x cannot equal 2. So what that means is I can use every x value, every real number, except 2. So looking at number 2, it says state the domain given that f of x equals x plus 3 all over x squared minus 25. So again, state the domain. What does that mean I do? I take my denominator of x squared minus 25 and I set it equal to 0. Well, this is quadratic, so I got to think about factoring. This is your difference of squares, and it's going to factor into x plus 5 and x minus 5. Then we need to set each one equal to 0. So either x plus 5 would equal 0, or x minus 5 would equal 0, and we'll solve each resulting equation. Subtract the 5, and you get x equaling negative 5. Add the 5 in the other equation, and x would equal positive 5. So these are the two values I do not want. I do not want x to be negative 5 or positive 5. Why? Because that's what would give me a 0 in the denominator. So with set notation, it's a set of all x's such that x cannot equal negative 5 or 5. And yes, you could put plus or minus. So again, make sure you understand what domain is. It just means with a rational function, you do not want your denominator to become 0. So set the denominator equal to 0, solve that equation, and then get rid of those values.